Today's topic is moment of inertia of a rod. Moment of inertia of a rod. There are two cases. Number one is moment of inertia of a rod about the axis passing through the midpoint of the rod and perpendicular to the length of the rod. Passing through the midpoint of the rod and perpendicular to the length of the rod. This one is rod. So total length is L. At the midpoint it is L by 2. This one is axis, which is passing through the center of the rod. It is rotating about this axis y and y dash. The length of the rod is capital L, and its mass is capital M. It is rotating about the axis, that is y and y dash. Is the axis of rotation. We want to find the moment of inertia of this rod. So consider the small element. This one is the small element. Its thickness is dx and distance from center is x. Consider any small element of thickness dx at a distance x from the center O. So the mass of this element is m. Mass of this element is small m. So we want to find the value of small m in terms of capital M, because total length L length has mass, that is capital M. So unit length has mass, capital M upon L. We want to find the mass of length dx, that will be small m into dx divided by L. That is the mass of the small element. This small element is rotating about the axis y dash. So the moment of inertia of this small element about y dash, that's di, will be m into x square. M is, we have already found, that's m upon L into dx. So di will be, is here on putting the value of m. Di becomes m upon L into dx into x square. So di is m upon L x square into the moment of inertia of the rod about y of means this small element dx. We can also consider the small elements from center, this one and so on, from 0 to L by 2 towards right and from 0 to L by 2 towards left. So the total moment of inertia, we can assume these types of small elements from 0 to L by 2 on both sides of O of center O. So the total moment of inertia of the rod about y dash will be I is from 0 to L di what? This 2 time 0 to L by 2 that's di. On putting the value of di we get I will be 2 integration from 0 to L by 2 m upon L x square and dx. M and L are constant, so I will be I is 2 times into m upon L and the integration of x square dx from 0 to L by 2 because of integration of x to the power n is n x to the power n minus 1. So we can also write I will be 2m upon L into x cube by 3 from 0 to L by 2. I is 2m upon L by 3 into L by 2 to the power 3, that's minus 0, means I is 2m upon L 3L into L to the power 3 divided by 2 to the power 3, that's 8. It implies that 2m into L cube divided by 3L into 8. It means the value of I is m L square upon 12. The moment of inertia about the axis passing through the midpoint of the rod and perpendicular to the length. The required expression for the moment of inertia. Because of I is mk square, so we can write k square upon L square is 1 by 12. Because of k square upon L square is 1 by 12, or we can also write, it implies that what is the value of k? K will be L by square root of 12. It may be plus or minus. Now the second point, moment of inertia of rod. Moment of inertia of rod about the axis passing through one end, passing through one end and perpendicular to the length of the rod. This is the rod, its length is L, total length is L, mass is capital M, it is the axis passing through one end, it is Y, and Y dash is rotating about this axis. The midpoint of the rod, this is Ly, with the angular axis which is perpendicular to the axis of rotation and passing through the midpoint of the rod. We can also say it is G. This perpendicular distance will be Ly to the rod of length L and mass M is rotating about y dash. We have to find the moment of inertia of this rod about y dash. To find the moment of inertia about y dash. So consider another axis which is parallel to y dash and passing through the G, center of the rod. Consider another parallel axis. Another parallel axis means parallel to y dash and passing through the center of the rod. Through the center of the rod. The distance between the axes will be L by 2. So we can apply the parallel axis theorem. Moment of inertia I of the rod about y dash, that will be Ig plus m into the distance, square of the distance between the two axes, that is ml square by 2. Here is I y dash, that will be Ig means m l square upon 12 plus m l square by 4, means that's I about y dash, that will be m l square into 1 by 12 plus 1 by 4. I becomes I y dash, it becomes m l square, and 12 is LCM, that is 3 plus 4, 1 by 3, that's ml square by 3. The moment of inertia of the rod about the axis passing through one end. This way we can easily find moment of inertia about any axis which is perpendicular to the. Now special cases. Question: find mi of a rod of length 8 meter and mass 10 kilogram about an axis perpendicular to the plane, perpendicular to the length of the rod and passing at a distance 2 meter from one end, is given mass of rod, that's capital M, is 10 kilogram, length of rod is capital L is 8 meter. By figure we can save the rod, its length is 8 meter and mass capital M is 10 kilogram. The axis which is passing through 2 meter, its distance is 2 meter. Axis of rotation. Cannot actually passing through the center of this under axis, because total length is 8 meter. Moment of inertia mi of rod will be Ig plus m into the square of the distance between the axis, 2 square. Here Ig is m l square upon 12. So we can also write that I will be m l square upon 12 plus m into 2 square. On putting these values, m is 10 kilogram into L is 8 meter divided by 12 plus 10 into 4. That's I will be 10 into 64 divided by 12 plus 40. That's 160 plus 120 divided by 3. It implies that the value of I will be 280 by 3. 280 by 3. Or the answer is 280 by 3 kilogram into meter square. The answer.